everyone. Welcome back to Math Academy. My name is Inifon Ebo. In today's video, we will be discussing integration. And integration is a part of calculus in mathematics. For you to understand the concept behind integration, first, you have to understand what is a function. You have to understand the concept behind differentiation. And if you check on our previous videos, we have all of those topics. But before we start, please remember to subscribe to the channel page and remember to click on your notification button for more videos. So like I said, integration is the antiderivative. What is antiderivative? What's the meaning of antiderivative? It is the opposite of what you did on differentiation. Remember, under differentiation, we were asked to differentiate a function like this. You're asked to differentiate a function like this. Automatically, you are asked to find the differential coefficient of this function. And the first thing you have to do is to do your dy dx, differentiate y with respect to x, and do what? Remember the concept, the times and take concept, the times phase. So you multiply phase, and you do what? You subtract 1, and that will be what? 1. So if you differentiate this function, this is what you have. Now, in integration is the reverse of differentiation. What do you mean by the reverse? First, you do what? You multiply, and you do what? You time, you remove. But in integration, we do what? We divide, and we do what? We add the power. So now let's go. If you are asked to integrate this function, the symbol for integration is what? This. Anytime you see this symbol, you know that this is what? The integral symbol. And this automatically is telling you that you are asked to do what? Integrate that function. And we also have what? A integral what? Constant. At the end of your integration, you always bring in what? Constant of integration. Now, let's cross multiply this. If you want to integrate the function, the differential coefficient of this, will we get back the question? Will we get back this question? That is what we mean by antiderivative. So let's go, we cross multiply this. We have what? Dy. We have that our dy is equal to what? 2x dx. Now I want to integrate these two so that I have what? Integral of dy, integral of what? 2x dx. Now to integrate dy, you have what? Y. If you want to integrate 2x, remember you do what to the power? You add the power. This is 1 already, plus 1, and divide by the power. Remember in differentiation, we first of all multiply before we subtract. But under integration, we do what? We add before we divide. So that we have what? Y equals to what? 2x squared all over what? 2. And this cancel this, so that you have what? That your y equals to what? X squared. Remember the constant of integration. But now, aside this constant, you see that we have gotten back our question, which was what? Y equals to what? X squared. We have gotten back our question, which was what? Y equals to what? Our x squared. So, when we say that integration is the antiderivative, it simply means that if a function is given to you to find the differential coefficient, you can find the differential coefficient of that function. But if you integrate that function, the differential coefficient, you can always get back what? The real question. So, without saying much, let us see how we can integrate more. If a function is given, if you are asked to integrate this function, x cubed dx. Remember, anytime you see this symbol, you are asked to do what? Integrate. They may not write in your question, integrate this, but seeing this symbol automatically tells you that you should do what? Integrate this function. So you write your solution, bring out the function, x cubed. What do you do when you are integrating? You add 1 and divide it by what? The power, so that you have what? X raised to the power of 4 all over 4 plus what? C. Don't always forget this C. We are also asked to integrate this function. I hope you are seeing well. You can understand what I'm doing. We are asked to integrate this function, x squared dx. You can rewrite this under indices, the law of indices. That is a negative index. I can rewrite it as this, x minus 1 minus 2 x. I can rewrite this as this. I'm not doing anything wrong, so that I can integrate very well and bring it out by saying minus 2 plus 1. Remember, we always add the integration all over the power plus what? C. And that will give me what? Minus 2 plus 1 is what? Minus 1 all over minus 1 plus C. And I can rewrite this. I can rewrite that as what? You know, we have what? X minus 1 all over minus 1 plus C. I can rewrite it as what? 1 all over 1 x plus C. And this minus is still B. So that is the answer for this. For lastly, if you are asked to integrate a polynomial function of such, if you are asked to integrate this, please always split it, integrate them individually. What do I mean? This 4 is a constant, so I can bring it outside. Plus what? 3. Integral of what? X squared minus 1. Integral of x dx. I'm integrating them individually so that x cubed, if I'm adding 1, that will be what? Plus 1 all over 1. 4. Remember, there is 4 here. Plus what? 3x squared plus 1 all over 1. 3 plus minus x 1 plus 1 all over 1 plus 1 plus c. So that if this 4 cancel this 4, this 3 will cancel this 3. And I'm left with what? x4 plus what? x3 minus x over 2 squared plus c. And that is your final answer. So under integration, the constant behind integration is what? Divide, add 1 and do what? Divide the power. So we have what? A, D. Remember, the constant in differentiation was what? Times and take. But the constant behind integration is what? A and D. So you add 1 to the power and you divide it by the power. We also have different integral problems. We have integration, partial integration, we have integration by substitution, we have partial fraction integration. We will be discussing all of that in our next video. Remain